So I'm here with Johanan Raatz. We have had one previous discussion on this channel. It is still public. You can go back and check that out. Actually, I'll leave the link for that in the description. But recently, I've been revisiting a book that I bought a few years ago, actually. This is the Quantum Hermetica. And as many of you guys know, I identify as a perennialist, and Hermeticism is kind of one branch of the perennial philosophy, broadly speaking. But the argument of this book is that one Hermetic document in particular, the Kybalion, aligns extremely well with modern physics, and there are extensive arguments from modern physics research corroborating what's said in the Kybalion, and we spin off into some speculations about the source of all of this stuff, and it's a really fun read. But as I was reading through it, it occurred to me that a lot of these points are similar to arguments that Johanan was making years ago, back probably 2014, 2013. And I've always been interested in what Johanan has to say as someone who's much more deeply embedded in the physics background than I am.
I've seen that book myself. I think we discussed that a bit in the last time. I had a friend, Kyle Allender, who was making videos on it for a while. He was actually my kind of protege, and then I saw him starting this series on it, and I got the book, and it's very interesting, the parallels in there.
Yeah.
I almost wonder if they might have been watching my stuff or something.
A lot of people do, so I wouldn't be surprised at all if that was the case. Also, E.C. Winsper, who is a Platonist on YouTube, I've also had an interview with him, did a review of this book relatively recently. It seems like a lot more people are starting to look at it. I have recommended it in the past. But it's a little bit dense and hard to get through. So hopefully Johanan can help us negotiating some of these arguments and examining some of these concepts. So the basic outline mirrors the structure of the Kybalion itself, which I believe was published in 1908. So it's not an ancient Hermetic text, but it does mirror a lot of what's said in the Corpus Hermetica. That is one argument that E.C. Winsper actually gave, that the fact that the Kybalion has these corollaries to modern physics doesn't necessarily mean that ancient Hermeticism does. I'm not an expert on the Hermetica.
Got it from somewhere, though.
Yeah.
It's interesting. After watching, I saw E.C. Winsper's review sometime back, and it was interesting because the mentalism and correspondence concepts do seem to fit the Hermetic framework, okay? They seem to have had that. But then it raises the question, there was the other, material on vibration and so on that seemed to fit into this, right? It was part of the Kybalion framework, and so it seemed like the Kybalion was getting it from two separate sources that were compatible in some way. And a friend named Trevor I talked to about this, who is a bit of an expert on certain things. He's actually he's a Buddhist, and he knows certain things that are Eastern. And he was suggesting, I forget the guy's name. So they don't know for certain who wrote it, but there is a suspicion that there's a man named William Walker Atkinson who wrote it. It's similar to some of his writings. So, it's obviously pseudonymous, so we don't know if it exactly is him, but people have some theories that it might be him. And the theory was that he got it from, if it was him, the theory was that he got some of those other concepts from spiritualism at the time, right? Which was kind of associated with Madame Blavatsky and so on. The point is that these physics parallels exist, right? So if they exist, they have to come from somewhere. Like he said, she got them from India, from Vedic. And it makes sense because the Vedic material would seem to fit, if Hermeticism has mentalism and correspondence built into it, that seems to fit, Indian thought at the same time, right? And so it's conceivable that he kind of combined the two into a unified.
Yeah, and many people speculate Hermeticism in large part derives from Platonism.
Basically, yes, in a certain sense, but the catch is that Platonism actually derived from the Egyptian material, from what I'm told. It was told in mystery school simply that Pythagoras went there and got it, and then he imported it back to Greece, and then he they repackaged it as Platonism.
Right.
And really it was Egyptian material. And
that is probably one source of Pythagoreanism, Platonism. Almost definitely it is. The conventional dating on the Corpus Hermeticum is 2nd century BC through about 2nd century AD.
Right.
But we only get the documents that survive in the dialects that existed at that time from the surviving.
Right, and they mentioned that
they're reiterating stuff from.
Yeah, and they even mentioned in the Quantum Hermetica that the concept of authorship was different back then. It wasn't like who wrote this particular text, but who originated the ideas. And so the point is they were written down again there. That's the oldest surviving written copies. They were attributed to this figure called Hermes Trismegistus. But the point is that ancient authorship, people try to date it that way, and they're saying you can't date it that way because ancients had a different way of looking at authorship.
Yeah, and it was normal to emulate prior authors. Like people wrote in Plato's name, people wrote in Aristotle's name.
Yeah.
Very common. So
the actual author was the guy who, according to the ancients, is the guy who originated the ideas, and so it simply is a repackaging. Especially because it was the same place. I mean, it was Egyptian, but it was like late antiquity. And you look at the exact. I mean, you said was it 2nd century? Was it?
Yeah.
Okay, well, that was around the same time the Library of Alexandria burned down, and same location too. And so it wouldn't be surprising if it burns down and they repackage it. They have to rewrite them essentially. And well, who's doing the rewriting? It's ancient Greeks.
Exactly.
Late ancient Greeks, late antiquity, and of course they're going to use Greek writing because they're the authors in our modern sense. They're just not the authors in the ancient sense. So,
right. So the one other thing I just want to get your opinion about on the Kybalion is that 1908, I mean, we are in the era of kind of incipient quantum mechanics. So some of this could have come directly from the physics of his time.
Not exactly. So quantum, there's a distinction between quantum mechanics and quantum physics. I mean, there is a general sense in which quantum physics is quantum mechanics. And there's, in a popular sense, everyone sees them that way. Quantum physics actually has to do with the quantization of physical properties such as light and electrons and so on, right? And it was discovered they're trying to solve something called the black body radiation problem. And they were predicting that certain properties should shoot off to infinity. A black body should radiate infinite energy and something at a certain point, and they don't. And they're wondering why this was happening. The normal equations were predicting that they should, and they weren't. And so Max Planck then went in and said, well, how do we solve this? How do we make this equation fit the actual curve we're getting? And so he basically put in by hand, he recognized that if you put this constant in by hand, which we now call Planck's constant, that the problem went away. And then basically that constant, if taken literally, would mean that light was quantized. It became a little pack. He didn't even think of it as anything special, like it was like literally particles, because at the time they didn't know about particle wave duality. Young from the 1800 double slit experiment. So he was actually just seeing this as a mode of transmission. It's transmitted in little packets, still waves, but it's transmitted in little packets. So he just thought it as transmission and reception of little packets, not as a literal particle, but that this still explained the problem. And they got rid of the black body radiation problem. And I think they had, I forget when the photoelectric effect was 1905. It was the same year Einstein got his other, and that one still can be understood with, just quantized transmission of light, essentially. And at that point, that's literally all quantum physics was. So this whole notion of particle wave duality actually did not exist in 1908. So that whole thing you get with vibrations, where there's this, they're describing everything has vibrations, and then, oh, by the way, these vibrations behave in a non-local fashion. Like they actually mentioned, like they don't say non-local fashion, but and this is just, if you want, I could, suspend disbelief or whatever, because it's a kind of a controversial topic, the whole issue of psi, but they were using it to explain telepathy. So forget whether or not that's a real phenomenon, but just, you can have fun suspending disbelief on that and say, well, imagine it was real. They're saying these vibrations explain that, right? Well, if they were to, in some hypothetical world, how would they do that? And so, as you know, if you're driving down a road, through the country, you're listening to a radio station. After about 50 miles, the radio station is going to peter out, and you're going to have to pick up a new signal, right? And that's with the powerful transmitter. Whereas, with brain waves, it's about a quarter of a hertz, right? It's not going to go. It's going to basically transmit into your skull and stop. You're not going to be able to use that to reliably transmit data like the way you would have telepathy. So they're saying these vibrations are, mediating this telepathy. Well, you think about that, hypothetically, what would that be? That's kind of parallels what Einstein called a spooky action at a distance, right?
Right.
That's very much a non-local vibration concept. So actually, when you say that, no, it couldn't have gotten that from quantum mechanics, because quantum mechanics did not exist yet. Quantum physics existed at 1901 and onwards, but that was at that point. The only real big developments in quantum physics were the quantization of light, of transmission of and reception of light, and then also the fact that electrons would only get kicked out of orbitals with quantized transmission. You know, it was below a certain quantized, a certain frequency, you won't get electrons kicked out of certain materials. You need to have a specific frequency multiplied by Planck's constant in order to get them kicked out. And so that was literally all that was known about quantum mechanics at the time. Maybe a few other little details of that nature, but it was literally to do only with the quantization of the transmission and reception of light and how that affected matter and so on. And so the whole business with the, because obviously at that point you're going to ask the question, well, is it a particle or is it a wave, right? Because I mean, for all this time, this last 100 years, before that 100 years, we thought it was, a wave from Newton onwards, or from Newton to Young, and then from Young onwards, for the previous century, there was this. It's kind of funny, but it's just like the Young's experiment was in 1800, and then this hint comes along that it's particles almost exactly 100 years later, 101 years later, but it's this nice little neat punctuation. But so
that all over history of physics.
Yeah.
One thing I did notice is that a lot of the language of the Kybalion, like the ether, fits in well with like Maxwellian.
Right. I mean, that one is. I mean that. Well, I mean that you can say that exists if you want to. I mean, people say the ether doesn't exist, and that is technically, in the way that we're talking about ethers, that is a true statement.
Mm-hmm. Right.
But it's. I mean, if you can also say though that's a kind of a too broad way of talking about the ether, or too narrow way of talking about the ether. Like you can still think of the ether as anything existing in empty space there. That's. So basically, an ether with properties of a fixed reference frame does not exist. But you can still talk about an ether in the sense of a 0-point field or space-time itself, or both. So that's a. I mean, when I see that, I recognize that's obviously a language of that's 19th century language speaking. Einstein was around, he did his theory of relativity in 1905, 3 years earlier, but that wasn't really popular at that point. People didn't have the internet then either. It wasn't, we suddenly have this thing out and, it spread around. People still talked about the ether. It was a popular, concept. So I just see that as an artifact of, 19th century language talking there.
Right.
But when you think about that, though, you could simply, in a modern context, you can replace that with the 0-point field or space-time or both. So that's not a difficult thing to just recognize that as a historical artifact of the times and update it to our modern concepts.
The author of the Kybalion had bits and pieces of what would become quantum mechanics, but you think there's still too much in there given his time.
Very, very specifically, those developments did not happen yet. The notion of everything having vibrations of that sort, that was 1926. So, yeah, it doesn't fit the history of quantum mechanics. The history of quantum mechanics starts with transmission and reception of light quanta in 1901, and then there's Einstein's photoelectric effect in 1905, and then you have to scoot 21 years forward to get to actual particle waves. That's you might think naively that it was influenced by quantum mechanics, but no, it wasn't. It was because quantum mechanics did not yet exist for another 13 years at that point. So
so there's something to be explained in any case about,
and then it gets worse when you go on, like for example, the non-local effects of quantum mechanics. Well, that first appeared with Einstein's challenge to quantum mechanics, saying if quantum mechanics is true, it's going to imply non-locality. Non-locality is absurd. Therefore, quantum mechanics has to be false. And well, it turns out that it would be absurd. It would be absurd in this sort of, classical material universe. But then we discover, we got Aspect does his Bell test in 1981. It's like, wait a minute, that spooky thing actually exists here. That's an actual thing,
Hmm. Right. Okay.
So yeah,
So
that would be that goes out later. That's 1935. That's
yeah. So there are some anachronistic details in the Kybalion that require explanation, which lends credence to the general hypothesis of the book when it comes to that, and we'll get to all of that. But the
I think it's
structure,
more anachron. I noticed it gets more. I saw that chapter, and then it gets more anachronistic the longer you go in. Like
okay,
then it goes to the fact that the universal wave function has a zero. The Wheeler-DeWitt equation famously has a zero Hamiltonian, which means zero energy content. And in the Schrodinger equation, when you have energy in the Schrodinger equation and you solve for a wave function, that comes out in the k value or frequency of the resulting wave function. So the wave function will be basically, the universal wave function is frozen, which by the way it is because it's outside time. So it just gets worse the farther along you go because it's small anachronism. I mean, it's still 13-year anachronism is still spooky, right? It's like, well, how did you get this 13 years ahead of your time? But then it just gets worse and worse. And it's like, whoa, wait a minute, these anachronisms are getting way. It's starting to becoming a bigger and bigger disconnect, and then they finally get to the whole particles being unified with space time and so on. You're like, oh, by the way, I recognize this. You can actually get, if you want to get a really big anachronism. This wasn't mentioned in the book, to my knowledge. I mean, they mentioned the emergence of space time from entanglement in the book, right? But they mention it as an argument for mentalism, right?
hmm
They weren't arguing that was in the Kybalion. I recognize after the fact that you can actually take some of the statements they bring out of the Kybalion and use that in reverse to argue for emergent space-time from entanglement.
okay, maybe we can look into that in a second. I just want to give the outline of
Okay,
the book.
go ahead.
So it mirrors the structure of the Kybalion, which I do recommend reading for its own sake as well. It is a very mysterious document, as you're hearing. So the first section is the principle of mentalism, basically a statement of idealism. The second chapter is the principle of correspondence. Then we move to the principle of vibration, the principle of polarity, the principle of rhythm, the principle of cause and effect, and then last, the principle of gender. And we will get into what all of those mean. But let's pick up where you just kind of led us to with the principle of mentalism and the idea of emergent space-time. So maybe first you can give kind of a primer on emergent space-time, and then you can explain how you can actually derive that from the Kybalion itself.
Okay, so emergent space-time, it comes about as it's a result of quantum gravity. They were trying to unify the equations of quantum mechanics and relativity for the longest time, and they simply would not fit. And well, they recently had this, not super recent, but last, I think it was 2013 or so, the ER equals EPR correspondence came out. It might have been 14, but they basically used holography to show that, which is a kind of emergent space-time, but it wasn't the full shebang yet. You had a two-dimensional quantum field, essentially, it's called the ADS-CFT correspondence, generally speaking. But basically what happens is you take a two-dimensional quantum field, and that translates over to a three-dimensional space-time. The information encoded on a two-dimensional quantum field is identical to a three-dimensional space-time. And so from that, they then did this little step to something called the ER equals EPR correspondence, where they took two black holes. And EPR is, of course, Einstein, Podolsky, and Rosen's famous, thing they said couldn't exist. And then ER is Einstein and Rosen's thing that they said could exist. And it's kind of funny because they then showed these two things are the same thing. They literally came up with the same ideas except for Podolsky. And it turns out those two things, one thing they said couldn't exist, one thing they said could exist, are actually the same thing. And so they kind of proved themselves right and wrong at the same time there. But anyway, you have two entangled black holes. And those two entangled black holes, it turns out when you plug that through the holographic principle, the entanglement, of course, is a quantum state, okay, a state of a quantum field or a quantum particle or anything in quantum superposition, just a quantum state in general, which could apply to a field across the surface of a black hole. And you have two entangled event horizons. When you translate it over to 3D, you get wormhole mouths. And so it's basically those two entangled black holes form the twin mouths of a wormhole. And so that was the discovery of ER equals EPR. Then that led to the realization, well, what makes a wormhole, right? You have two locations, and those two locations are now in some sense the same location, even though one's here, one is 1,000 light years away, they're actually the same location. And then they're the same location. Well, how do you make them the same location? You have to have creates a bridge essentially. That identity of location is the bridge that, you can then jump across from one point to the other, and you're, 1,000 light years away or whatnot. So then you realize, well, how is space defined? Go back to middle school geometry. You're asked to make a point, a zero-dimensional space. How do you define it? You start with a point, right? How you get a one-dimensional space. You add another point, you draw a line, right? Two-dimensional space, you add a third point, and then you can define a plane and so on and so forth, right? So, and in physics, it's, the physics follows the math. Space is defined by a location. And if you think about it, if you have a space without locations, you can't really call it a space. I mean, space is the continuum that distinguishes locations. And so there's no points, there's no locations, there's no space. So space comes from locations, and if entanglement is defining locations, the difference between locations, then it follows that, and locations term defines space, then it follows that entanglement is defined by space. And so that was the big clue. ER equals EPR was the big clue, and they were trying to, they're playing around with that for some time. I think they had another one in between there. It was called the ADS Mera correspondence, which is Mera is multi-scale entanglement renormalization ansatz. It's basically it's a fancy name, basically describing a network of entanglements that give rise to a space-time. And then, well, one of those is called the anti-de Sitter space. It's not our space, but it's very similar to our space. And then it raised the question: can you get to full-blown de Sitter space, which is our space? And well, as of last year, it turns out that you can. They call it the DS Mera correspondence now, and you can derive de Sitter space from entanglement, and that was proved just last year. So, yeah, so that now that's where they've gotten so far. They have this really cool way of turning space-time into entanglement.
Entanglement producing space-time.
Yeah.
Yeah.
And so
Let me just rephrase in very simple terms what I gathered from that. So EPR equals ER. EPR is basically entanglement, and ER is wormholes.
Correct.
Right. So these are the same thing. So entanglement means there's the shared quantum state non-locally, and there's one identity in terms of location. When you have is that a general principle that when two particles are entangled, they share location? I thought they shared a quantum state. But
well, no, by itself, it's not. I mean, like that was the realization is ER equals EPR realized that they share location essentially, or at least in the case of the black holes, two entangled black holes, they share location. They're separate, right, but they're also the same place. So therefore, that's they're two places, but they're also connected. It's a wormhole.
Yeah. Obviously, it seems mysterious, and that result originally derived from event horizons of black holes, supposedly.
And it makes sense in a way if you think about entanglement. I mean, entanglement. I mean, it technically doesn't transmit classical information. I mean, there's obviously quantum information that is unified across the whole. But if you think about it, this wave function, you have to have a wave function collapsing simultaneously here and over there, right? Well, that's kind of faster than light. I mean, it technically doesn't transmit data, but at the same time, it violates the spirit of relativity. And you realize, well, how do you get it to avoid this? I mean, there's internal information there. You can't get at it, but there is something there that's connecting, the wave function here and the wave function over there. It's the same wave function, but when you collapse it here, it's not taking the speed of light to, produce a collapse over there. It collapse doesn't happen at the speed of light. It happens instantly. And so if you think about that, how to avoid a real problem with relativity with that, you have to put it outside space-time. If you're not in space-time, there's no issue of travel because travel happens in space. And so if you think about it, the fact that there is such a thing as entanglement is a very solid clue that entanglement, the quantum state is not in space-time. It can't be in space-time because it violates relativity if it is. And so you have this really kind of cool conclusion where but yeah, entanglement can't be in space-time. And then we later on discover, well, that's why it's not in space-time. It's because space-time emerges from it.
Okay. I do want to dig into all these points, and I'll offer what, objections or thoughts I can with regard to faster than light transmission of information with collapse. It's like you said, entangled particles can't transmit information faster than the speed of light, but still the collapse happens instantaneously. And so, for example, if we have an upspin quark over here that's entangled, it was part of an entangled pair, we know that the other quark will be downspin. The second that we look at the one quark, we know the state of the other quark. It's instantaneously that collapse occurs. Now, one way that I've thought about it is in terms of a many worlds interpretation, where the range of configurations consistent with our observation collapses, but there's no physical event of a collapse anywhere. It's simply that the number of possible contextualizing universes is scaled down. Does that not work to get around this faster than light issue with collapse? So the idea would be that no physical collapse is occurring anyway. It's that the superposition represents a range of possible universes in which we find ourselves. When you observe one part of an entangled system and collapse it there, so to speak, you are simply rendering yourself as an observer inconsistent with that range of universes that you were previously.
Right. Well, I see what you're getting at. Okay, so yes, but then you got to ask the question. Well, another way of saying that is to say that those universes are splitting apart, right?
In real terms, or in terms of the perspective that you're taking?
Both. Like it's
well,
they're in superposition. The two universes are in superposition in the wave function, and then now they're not. You measure the two. There's a decoherence. The two universes are now split, right?
Sure. Yeah.
Okay. Well, two things about that. Number one, if they're decohered, well, you have to ask the question: why is it decohering? Faster than light. You just move the problem over to decoherence, right? The second thing is there's actually a problem in MWI that's associated with this. It's called the preferred basis problem, and that is, let's say you have a classical trajectory in one universe, a classical trajectory in another universe, and so on, or you have a wave in one universe. Well, the whole notion of the wave is that it is the product of a superposition of these states, right? So if it's only classical trajectories in each universe, then where does the wave come from? Why is there a wave rather than a particle sometimes, right?
Yes.
And so there's the question. And so, well, it relates to the issue of collapse, right? And, or decoherence. Why is this, whatever mechanism explain, how to get around this has to explain, why when it's a wave, it only transitions to a particle or a pair of particles faster than light, right? And it turns out there's a solution to this problem. The catch is, and this is kind of hilarious because materialists love to use MWI as a tool trying to save materialism. But the problem is that in order to salvage, in order to explain the preferred basis problem, MWI needs emergent spacetime.
Oh,
and so,
okay.
Sure, you want to have your multiverse. That's fine. I don't have a problem with that. But your multiverse is going to need emergent spacetime, which then, if you want to use it for materialism, it kind of defeats the entire purpose,
Right. Yeah. Okay.
We have an immaterial multiverse, and that can explain our materialism.
Not quite. Sure. Okay. The way that I use MWI is unconventional. I actually have an interpretation, loosely speaking, a philosophical interpretation up on my channel. Maybe one day you can check out. You think
going
about
in
it.
the direction of many minds now, actually, because it is it is an Everettian view, but it's also a Copenhagen view. It's like the hybrid child of both.
Right. I think pieces of several different interpretations are ultimately going to, like relational, many world, Copenhagen, they'll come together at some level. So in any case, going back to this, if entangled pairs are sharing location, sometimes location in some way, location is defined by entangled pairs. This kind of, again, a tangent, seems related to how loop quantum gravity talks about the emergence of space from quanta of gravity. And so their kind of network of relations defines then the topology of local space-time from the bottom up. But it seems like this is a slightly different, it's related, but it's a slightly different concept that you're talking about. So how prevalent is this view that space-time-ism is this like established fact, would you say, in the physics
Yeah, I
community?
would definitely say that is a satellite. Because so here's the thing: people always assume that because they'll say nothing is certain in quantum gravity because we don't have a theory of quantum gravity yet, therefore you can't use its results. Well, the problem with that is that kind of obscures. There are disagreements in the quantum gravity community. I mean, there's string theory, there's loop quantum gravity. Those are the two main ones. And the runners-up would be, things like causal dynamical triangulations and so on. Well, the thing with this is that both the major approaches of quantum gravity and all the runners-up. I mean, if I looked at it, I forget what's after causal dynamical triangulations, but basically, like the next 3 or 4 approaches after that, they, as well as the main two, all use emergent spacetime. And so, and there's actually there's a quote, I can't find it right now. I forget who said it, but he basically, the guy was basically pointing out that when people say that we don't have a theory of quantum gravity, that obscures what is actually known in the field. When there are things that we do know in quantum gravity, and the one thing that is universally agreed upon by almost everyone, no matter what theory they competing theory they hold to, is that space-time is emergent. And so, like,
Right.
when we say that there's not sure, we don't have all the details figured out, but we do know that it's everyone in there is saying it's emergent, no matter which field you're going to. And there are some things that are we're getting to better now that are being known either for certain or functionally for certain insofar as you can do it with, because it's quantum gravity is notoriously difficult to experiment on. I mean, they were able to confirm holography there a year with that cosmological horizon study, that it fit the results slightly better than the standard model. But yeah, insofar as the theory is concerned, like the space-time arising from entanglement, that's like agreed upon no matter who you talk to. That's universal across the board.
Right. A lot of this, the authors, and they're actually, I should name the authors, Olivia and Ethan Palmer. That might be pseudonymous if I remember in the introduction, but in any case, the author goes over this relatively quickly, but they are exhaustive with their citations. So, I tried to look for some of these studies, and they dig pretty deep on some of these. Some of these I could not find online very easily. But in any case, yeah, that was very helpful clarifying the idea of emergent space-time. Now, I have one tension on this, because on the one hand, you're saying, and I know there's a way of putting this together, and it's probably in the book, I just don't quite understand it yet. But on the one hand, space-time is defined and emergent from networks of entangled particles. It is entanglement that produces space-time. But on the other hand, we say that it is information that produces space-time. So what's the connection between these entangled particles?
You can simply take that's just quantum information theory. You have basically, this is like Seth Lloyd stuff. They discovered sometime back that you can take everything in quantum mechanics and translate it into quantum information theory. So the two are equivalent theories, and it's you're describing these quantum states as information states, and and therefore anything you do inside of quantum mechanics can be described as quantum computation instead.
And when you say information states, are you saying that quantum states will be qubits? Or
Yeah,
what do you mean?
that's exactly. I mean, qubits. I mean, it's a super. When you talk about a qubit, it's a superposition of states. But then you ask, well, how do you, or of bits? But then, well, what's a bit? Well, a bit can be anything. A bit just means a difference. It's like, we define, on our classical computers as a 1 and a 0, right? Well, if you got a 1 or a 0, well, you could define a 1 could be spin up, a 0 could be spin down. You can use anything as a designator for that. So, yeah, it's a measure. Information in physics is simply a measure of differences, and anything can be a difference. So it's, yeah.
I think it would help viewers as well if you could just very quickly explain. I know you did just now, but classical information versus quantum information.
Okay. Classical information is there's a single state per bit. So you have, there's a 1 or a 0. This little magnetic piece of magnetic domain in your hard drive is a 1. Next one's a 0, and so on. A qubit exploits the superposition principle of quantum mechanics to place many ones and zeros in superposition at the same time. So a qubit can be a 1 and a 0 at once, and it can be many ones and many zeros at the same time, all in superposition. And so you're exploiting, you can use that for computation, and you can exploit, all parts of that superposition at once for and they actually had they had one example that was recent out. This was, they were worried that, early quantum computers were, they could only go like say 64 qubit or 128 qubit or something, but the earlier ones were like 32 qubit, and you could only, get so many superpositions. And then it starts to, as the technology improves, you got better and better qubit, rankings, more states per bit per qubit. And recently, I don't know how many qubits this was, but the cool thing with this one, the latest I had heard, was they had a quantum computer, and it's kind of cool because, I remember 20 years ago or so, they were actually talking about this as though it was a hypothetical. It's like, wouldn't it be cool when we have these quantum computers that can do things so fast one day? Like the theory tells us we can get these things done in, a 10,000 year, this would take 10,000 years for the supercomputer to do it, and we can do it in milliseconds. Well, that actually just happened now. There is a supercomputer that they said that performed an operation in a few milliseconds that a regular supercomputer, a non-quantum supercomputer, would take 9,000 years to do. And wow. I saw that, I'm like, whoa.
Is that
it really opens up some possibilities. I had this, this is totally tangential to the conversation, but I had this idea in biology. It was derived from something I learned in a chemistry. One of the professors said they had, or a grad student said they had a computer program that was able to simulate chemical interactions before they did them, because sometimes the chemicals were very expensive and they wanted to make sure a good idea was going to happen before they did the experiment. But they had this, a supercomputer there that was able to simulate chemical interactions, complex chemical interactions. And I realized, well, what is a biological cell? So, ultimately you break it down to multiple organic compounds, and each of those is a chemical. You could theoretically simulate an entire cell on a quantum computer. It's just a matter of computation. You could simulate an entire body. You would still have, you don't want to simulate each individual cell. You want to simulate, cells by type, and then you could have like a program that would be stamps out, this is, cell type A5 or B20 or whatnot. And you can just, stamp it into place when it shows up in a tissue in the simulation. But the computer power now, you could theoretically simulate an entire organism if you were able to upgrade the
yeah. What happens when they do
program?
That is the main question I have about that. But
I actually had an idea on that. This is totally tangential again, but what I wanted to use it for?
What?
This is totally dorky. I wanted to take a body plan of something, okay? And there's something called deep homology in evolutionary genetics. And it basically argues that, like, you have something that has, say like a rhino has a horn and has like a frill on the back, right? And you see like a chameleon, Seller's chameleon has the same thing, right? And so they're arguing that maybe the horn and the frill, they're showing up. It's not just a matter of convergent evolution, that they're actually tapping into some of the same genetics. It's lying dormant in the meantime, and they're exploiting that same genetics in different ways, right? And so I had the idea of, what if you were to get, to basically get a genome and simulate what would, try and run that genome out in the program and see what kind of body plan it would produce. And then you could kind of do a hack job through multiple genomes of, multiple traits you wanted. And you could put you say you wanted something that was like the body plan of a pachyderm, but you wanted to have like a tail on it, like a lizard, and you wanted to have horns and frills and maybe a beak on the mouth or whatnot. Kind of see where I'm going here?
I don't know that I approve of it, but.
And you get a billionaire who purchases an island off of Costa Rica.
Yeah, let's not. Let's just not even mess with it. That's my opinion. But okay, so going back to information just one more time, classical information is basically a specification of a difference in state, and the simplest possible difference in state is binary digits, kind of on or off. So that becomes the measure of information, classically speaking. But with quantum information, like we have the problem of things in superposition that aren't in one state. So we need a new kind of measure of information to deal with quantum systems. And then that ends up having a lot of practical effects. Is that kind of the gist of why quantum information is distinct? Because we have this
Yeah.
issue of
It's superposition. Yeah, it's information and superposition.
Right. Okay. That's fairly intuitive. Um, so one point that I wanted to hear uh, your input on is this idea that information requires, a conscious observer. The authors of this book don't really argue for that point all that extensively. I mean, there's a ton in here, so they can't go super in
Right.
depth on it. But what are the conventional views in information theory regarding classical and quantum information? Is the necessity of some kind of underlying substrate built into the definition of
No, they
information?
just use it
Why,
instrumentally.
why
Or
okay,
they treat information as a substrate of its own right, which is, kind
and
of
you
fits
think
with
it's
Platonism,
problematic?
actually. I mean, Platonism does that in a certain sense, but
Hmm.
that's the
Um,
vision of physics. They treat the information as the substrate. It's not attached to anything. It simply is just free floating information.
but the authors here say that to be information, it has to inform a subjective experience, right?
Right. Well, that's logical. That's where you kind of go further, and you can say, well, you can have consciousness. Then it's what's the substance? The substance is consciousness.
Mhm.
And people always bring up this whole issue of, well, you know it's not a conscious mind doing the observer, because it's we look at the experiment. Well, what is it? It's a photodetector or a camera or you know a film in the back. Well, yeah, that's true, but then the question is, well, who collapses that, right? And they're going to
Sure.
say, well, the environment collapses it before the mind ever gets to it. But then, well, wait a minute, are we forgetting something? I mean, quantum mechanics simply is, and they pointed out in 2020 they did the experimental demonstration of Wigner's friend collapses relative to frame. And so when you ask, well, what frame is, who says the environment is collapsed? Well, environments are collapse in general happens with respect to frame. So with respect to whose frame or what frame is the environment collapsed? And then you
Exactly.
get the issue of, well, if, I mean, we obviously have reference frames, right?
Hmm.
And so therefore, if we have a reference frame, you can say that it is meaningful to talk about collapse happening with respect to our reference frame. So, I mean, yes, the photodetector is doing its own collapse and so on. That doesn't avoid the problem, though, because collapse is relative to frame, and therefore anything with a reference frame can do collapse. And, it's kind of ridiculous. The whole notion of a reference frame comes from, the very first reference frame we're aware of is that of conscious observers, where we got the idea in the first place. So it's kind of ridiculous to say, well, the one example that we originally got reference frames from in the first place is the only one that doesn't really exist. Like, it's stupid. So yeah, I mean, so it doesn't mean that consciousness is especially collapsed in the wave function. Like arc lines are, the photodetector is doing it too, the camera is doing it too. Any interacting particle of any kind is doing it, but because they have their own reference frames. But the fact that we have a reference frame means that things are collapsed with respect to our reference frame. So yes, consciousness is also causing collapse. It's just a consequence of Wigner's friend.
Yeah, to have a reference frame, you need some kind of subjectivity. And maybe the elementary particles do have some kind of subjectivity, but they only make sense as a reference frame, not as an object. Objects exist within reference frames. So to be a reference frame, you can't be at the same time an object, you have to be a subject. I mean, that's the way I would think
Right.
about it. So one objection, a common objection that the authors respond to is the point that decoherence, and you referenced this earlier, decoherence leads to the collapse of large scale systems. I think Max Tegmark was one of the early people resuscitating this idea, like in the 90s. Apparently, he had rediscovered it from some earlier work. Remembering vaguely from a book that Tegmark wrote about this. But can you explain, like, what is the idea of decoherence, as opposed to just like the collapse of the wave function generally? And then why could decoherence not serve as an explanation alone? Why do you still need a conscious observer to
Well,
collapse
that's the
things?
thing. I'm not. Oh, okay, so from my understanding, decoherence it relates to the notion of, the multiverse with the two superposed states splitting apart, right? So, well, then the issue is, I mean, why does that happen? They're going to say it's an increase in entropy caused by an interaction, but I mean, a mind can, cause an interaction to occur, and if there's an interaction, you have an increase in entropy. So I don't see why that would really rule out a mind doing it.
It wouldn't rule out a mind, I suppose, but do you see that as a viable physicalist alternative for explaining?
Well, the problem I mentioned before is that, decoherence, if it's going to happen, it happens to happen instantaneously, in an entangled system, right?
Okay.
And, then that gets into the whole. So and of course, the issue of whether something is in superposition or collapse is related in MWI to the whole preferred basis problem. And once again, the only way to solve that is you need emergent spacetime. So, I mean, it's not going to, it won't bring consciousness in directly in that respect, but, when you have the whole notion of matter is that you have something extended in space.
Mm-hmm.
And if you take the space out, it kind of talk of matter becomes meaningless. So, and I mean, you can then, I suppose, go and say that information is matter, and some people try to do that, but that just gets kind of stupid, right? It's like, why you have, I mean, we obviously have mental information. Why do you need this second class of information? You're creating an artificial distinction that, I mean, you're rereading dualism, basically.
I was looking at a paper. To be honest, I just read the abstract and thought it was interesting. I think it's from 2017. They talked about an information mass energy correspondence, and I guess in whatever experiment they set up, there was some way of measuring the kind of mass or weight of information. Are you aware of any study to that effect, or?
I think I did hear about that. It makes sense. I mean, information, that's a known fact. You can take energy and translate it into Shannon information. I mean, that's the whole holographic principle relies on that. It's
Right.
The energy you're putting in the black hole is identical with the qubits on the surface.
In any case, all of this is going to have to emerge from the bottom up, from a domain of quantum information. And you have in the past mentioned several times this kind of, you even used an analogy to like Stranger Things and the upside down world.
Oh, I remember that movie. I thought that video I made that was a lot of fun.
It was a fun video to watch as well, but there's you have the idea that there's like a kind of underlying pure information realm equivalent to maybe Hilbert space or something like that.
It is Hilbert space. I mean, mathematically speaking, Hilbert space is a bit larger of a concept, but insofar as it's used in physics, yeah, that's when physicists talk about Hilbert space, they're talking about quantum probability space for the most part.
So all of this physics regarding location being defined by entangled pairs, space-time being emergent, the source of all of this is going to have to be a realm of pure information in some sense, and that is familiar to readers of the Hermetica or Platonism for that matter. So I think the author's point is certainly being made, and yeah, thank you, Johanan, for going through all of this with us and helping us to understand. So this was one of those parallels that made me think to ask you about your thoughts on the book and how good of a job they did. They mentioned Brian Whitworth, who he was a computer scientist.
Right? Yeah, the parallels of the virtual reality. He's popular. His parallels are popular. They're all over the place. A lot of people that came from him, but he showed you have this weird effect in physics, and by the way, there's a similar effect in virtual reality systems, and the reason is due to information processing. And actually, in some cases, it's been discovered that it's not just like a neat coincidence. They've actually demonstrated the connection. Like in one case, in general relativity, his analogy with general relativity was it's the system is slowing down because you open too many windows in your desktop type of thing, right? Mm-hmm. And that's why time slowed. Well, there's that's sort of true now. They had a guy named Ted Jacobson. This is way back in 1995. He had this theorem, and he showed that if you take if you start with the holographic principle, you just forget about general relativity, start with the holographic principle, and you bring in entropy, right? You can actually derive general relativity from scratch from it. And the reason is space time is generated from, in gravity actually is generated from this increase in information, which is, in gravity and general relativity obviously is involving this time dilation effect. So it's literally, you've opened too many windows on your desktop. The information increases, the time slows down. And that's actually physics. That's Ted Jacobson's theorem.
You can reconstruct the.
Yeah, like it's an analogy, but now it's no more than an analogy. It's now granted in a virtual reality, it's processed in our computer games. It's processed across the entire computer game, and whereas in reality, it's processed each individual point. So it's this area is going to be running slower than that area. And maybe like a good example would be an MMORPG, because that kind of goes in between both, right? So in MMORPG, you have one screen and you have another screen over there that there's, this area you've got a little city, you got a little dungeon over there, you got a forest in the next section, you got the goblin village in the next section after that, and you got to run across the map, right?
Yeah.
And let's say that there's a bunch of people who want to go and visit the goblin village all at once, and there's not many people in the forest nearby, and then there's another pocket of people in the city. Well, you run across the forest, you're going to be able to go through that faster, right? Go to the goblin village or go to the city where the market is, and suddenly a whole bunch of people, it's going to start slowing down, right?
Mm-hmm.
So you are in this particular case, if you could kind of approximate that to infinity, like the whole notion of calculus, where you have, you remember in calculus you have like integrals and you have or derivatives. You have basically the idea is going to average. You're dividing length by height and so on, but you're then doing it at smaller and smaller.
Yeah.
Okay, so it's like that. If you were to take that same concept and do it down to infinity, you get a pretty close approximation of general relativity then, because you'd have, the information processing at each individual point in space. Whereas, a regular single-player computer game would be the whole computer game. You wouldn't really see the effect other than the fact that the game slows down when you run too many windows. Whereas the MMORPG would be use some kind of a feel for it, because you would have in this space time is running slower. In that space, in this space, there's a whole bunch of characters. Time is running slower. We have more mass. The next space over, where you're pretty much empty, time is running faster.
Yeah, perceived simultaneity is dependent on reference frame, but then just like in general relativity, like a causal sequence has to be able to be reconstructed from all of the individual perspectives and shared in common. So that's actually a really close analogy. So then the last section of this first chapter, they go into some, physical models that make this, conscious substrate explicit. So one example would be conscious realism from Donald Hoffman. I read Hoffman's book, The Case Against Reality, which I thought was actually a real fun read. I also had a talk with John Vervaeke, and we kind of, I mentioned Hoffman in that talk, and he reacted very negatively and said, he had Kantian assumptions and all these various things.
Wait,
and
what was the talk that you reacted negatively to?
Oh, I was talking to John Vervaeke, who's a cognitive scientist, and I mentioned just kind of in passing Hoffman's theory, and he reacted very strongly against it, because it's a common. In fact, Hoffman preempts the objection that Vervaeke offered in his book, The Case Against Reality, where he says that just because our perception should be tuned to fitness payoffs in everyday life doesn't mean that we can't still ground theoretical truth claims, like scientific truth claims, at a deeper level, because the underlying mathematical structure of things should kind of.
Hoffman does that anyway. I mean, that's the whole point of his model. He starts with conscious agents, and he does ground it. It's just not at a ground. It's a level past, our physical categories.
But it's easy to misunderstand, I think, what Hoffman is saying, and to make him come out as more of like a noumenal phenomenal dualist or Kantian. That's Vervaeke's problem. But let's pass that for now and just list the other models. So conscious realism, informational idealism by Daniel Toker, quantum cognition in general, and there's a lot of different work that's been going on. We talked about that a bit in our last talk. the kind of anecdotal instances of how we make decisions mirroring the way that quantum
Oh
computation
yeah,
works.
I've done that in my videos. That's common in my videos. And I by the way, I noticed Daniel Toker's thing. It seems to be kind of talking about the same thing. I was, that was the whole integrated information theory application. There's actually I've cited this in my videos before. There's in one of Tononi's papers, he actually mentions very specifically that entanglement is identical to integrated information.
Which is the same as saying that the universe is basically a mind, like the
Or emerges from a mind. It's a simulation in a mind. Because, I mean, that's
yeah.
By itself, he's just kind of taking it over here. He's not looking at the larger picture. But when you plug that into what we know from quantum gravity now, space-time emerges from entanglement, that's space-time emerges from consciousness. But in the universal wave function, well, that's space-time emerges from a mind.
So maybe we won't go. They just kind of in passing mention these models: conscious realism, informational idealism. The sources are there in this book. If people want to look more in depth. I've been meaning to get around to actually reading Hoffman's, mathematical theory itself, rather than just his popular book. I wasn't aware of Daniel Toker. I still haven't looked into him. I am familiar with Tononi, and I really like his arguments, and I incorporate them in my own thinking in various ways. So, guys, a lot of these points in this book, I think, are worth looking into. I'm still getting a lot out of it, and I'm glad that Johanan has agreed to go through these sections with us and help us understand, because not everybody has the physics background of Johanan or the background of whoever these authors are. Kind of a mysterious, interesting book. I thought you guys would like it. We're going to continue this and go through the rest of the sections. So thank you guys. And Johanan, anything else?
I saw that someone gave me a PDF of that book, by the way, and that thing is that thing's explosive. If that ever thing goes viral, it's going to cause all hell to break loose.
Yeah, well, there's so many ideas, and to my mind, I mean, you have been one of the people out on the cutting edge of a lot of these sorts of ideas, physics-based arguments for idealism and related phenomena. So I do think
they're taking a whole other direction, though. They're saying they're taking that physics and they're seem like integrating into this sort of esoteric or occult science, and they're showing these parallels with things
that's what makes it enigmatic and interesting. But the basic physics arguments are hard to deny, and I think that there's enough different data points that you've put together and the authors of this book have put together that meet, it has to be taken seriously in any construction of a future metaphysics. Armchair philosophizing and a priori speculation is not. It's not necessarily that it's not enough. It's just that we have so many resources in the forms.
We can integrate the armchair speculation with the physics in a very rigorous to make it much more interesting than just mere armchair speculation.
Yes, and Johanan has been a big resource in that project. For me personally, also, this book has been a big resource. So we'll keep on investigating.
What's funny about that is that. I mean, I saw the references in that thing, and it's just physics, right? But they're taking the physics in such a way, and they're showing, they're combining the ideas in a way that you basically get the Kabbalion out of it. Which is funny because the Kabbalion is an occult document. It's probably the most famous occult document, but they have this thing. Now it's being said that this is all physics, and that's going to cause quite a stir, I think.
I'm sure it will. So we'll wrap up on our part today. This video will carry on to the next section. So take care, guys. All right. So today we're doing the principle of correspondence. Do you have anything to share in general, your thoughts on the chapter before we kind of look at it point by point?
Yeah. So basically it goes over what correspondence is and then shows direct physics parallels with it, which actually it follows very naturally from the physics behind the principle of mentalism. It's like literally it's the same physics, just like you're parsing it apart differently to show people like the mechanics in a different angle, sort of. And then it goes from there into it ties it to Jung's collective unconscious concept. Supposedly it shows the parallels with the Kabbalion again, but then it goes from there to pointing out how this ties into Jung's collective unconscious, and this is it. It combines basically the two nest together. So Jung's collective unconscious, subconscious, it combines with the principle of correspondence in a very meshed sort of way. And then from there, it kind of is interesting because then it goes into it forms the framework. This is probably, other than mentalism, and it's kind of like idealism. So it's not specific to Hermeticism. I mean, Hermeticism includes that, but it is not just. I mean, it's a ubiquitous thing. It's found in Hermeticism, but it's found in a lot of different, just regular philosophic idealism or Hinduism, or, you can find that anywhere pretty much. But correspondence is probably of the Hermetic specific principles, is probably the most foundational one. Mentalism be more foundational, but it's not specific to Hermetics itself. So what this then does, they show how this, once this kind of understanding of correspondence is grasped, it then is able to show how it is able to combine with Kabbalah to form what's called the Hermetic Kabbalah, which is kind of the grand unified theory of Western occultism. So the two main pillars of Western, the third one is sort of Neoplatonism, but it's part of the philosophy of occult science in a certain sense. So it's not by itself, it's like is it really not like a third pillar? It's simply the philosophy of the whole thing. But like, if there are two main pillars,
foundation, right?
Yeah,
the foundation. Those are the two pillars.
It's like Hermeticism and Kabbalah are the two main systems of thought, and they are not incompatible. They're not like separate systems. I mean, they are separate, but they're not separate in a way that they're like incompatible. They actually or like you just kind of like augment them together in kind of an ad hoc fashion, where you have an ice cream cone, you decide to glue on mustard or something onto it, right? I mean, that'd be kind of stupid, right? It's not like that. It's actually a very neat fit. It shows in the book, and they compare it to hardware and software. You have to have hardware, but you have to have your software running on the hardware, and one is looking at the physics of the mechanics of the hardware. The other one is showing the software, and it has a little bit of description about the hardware, but when you look at the details of the hardware, and you can see that it actually meshes. It doesn't describe it exactly the same, but it meshes very neatly with Hermeticism. And then they go into a further parallel, which was quite interesting here. This is from Kabbalah, and when you look at the Hermetic understanding of mentalism and where this comes from, and you combine it with what else the physics behind it, you then look over at the Kabbalah, and they have a description of what the book describes anyway. And this is it's crazy to say this because I'm just going to say what the book is saying, because it's this all seems kind of weird in its own right. But they're saying, they have this text from the Sefer Yetzirah, which is the oldest Kabbalist text in the world, and it has an uncanny description that sounds almost literally identical to a block sphere representation of a qubit, named after, not block as in BLOC, a wooden cube. It's BLOCH after Felix Bloch. And I looked at the reference for this, and I believe it was, let me see exactly where we have here. Chapter 3. I think it was like an MIT type document on some quantity, and they show us very specific. I can even like link this up later on if I do some kind of share screen button. Okay, so yeah, this is a block sphere representation, and then they reference this, and it's kind of weird because it's literally a very technical physics description of a qubit, and the equivalent description shows up in the Sefer Yetzirah, and it shows up in this emanating space, which is the realm beneath space-time, which was what you would expect a qubit to be, because quantum states are not in space-time, because they'd violate relativity if they were. So, but we'll get to that later. So,
right. The parallel from the Kabbalah, as I understood it from the book, and I haven't looked independently into Kabbalah all that much. I'm a little bit familiar with it, but the idea is that the kind of tree of life mirrors Neoplatonic emanationist models effectively. The connections between the different kind of points on this tree of life amount to the 22 letters of the Hebrew alphabet, and then the different way in which those letters can be combined form, if you take all of the possible combinations of those letters and map them on the outside of a sphere, where like there are kind of tunnels between the sphere, you might say, then the inside of this sphere represents combinations of states.
Correct.
These letters, and that's the same way that a qubit would sort of work with the
Yeah,
combination.
we'll get to that later because very specifically, and it's not just that; it's like a number of parallels with this, like how you operate on the sphere to achieve certain results, basically. And it's like this is they're describing a qubit, and I was quite astonished to see it's like this is, I mean, what it appears to be. They show the parallels. It's very definitely like whether or not it's what it appears to be. You can see that there's parallels apparently that this has this uncanny resemblance to a qubit in a very literal fashion.
So maybe when we kind of revisit this section in a moment, we can get a little bit more in depth on that. If we can, though, let's just go back to the basic idea here. It follows sort of from the definition of consciousness that we got, quantum mechanically speaking, in the last chapter, where like entanglement is the basis of consciousness in some sense. These entangled states exist beneath space-time in Hilbert space. That's the idea. And so basically, therefore, our thoughts exist beneath space-time in Hilbert space.
Yeah.
So we have then a kind of exegesis of the two Hermetic sayings, as above, so below, and as within, so without, in terms of this. And it does follow pretty straightforwardly here. So as above, so below. Well, why don't you go ahead and give the interpretation?
Yeah, so as above, so below. I mean, you have, well, there actually is an older concept of this, but we can get to that a little bit later, where they were taking, it was like an astrological concept where you have the stars above, and then somehow this mirrors what's going on the earth below. But that's like that comes from the notion of divination. But that would be, I would treat that as like a separate, I mean, that would actually come as a result of correspondence. But it's this is a more fundamental thing, which is saying you have this. I'm not sure you can think of the sky as like a metaphor for the heavenly supernatural realm or whatnot. But forget any of that talk. I mean, people have kind of interpreted that in, and there's not some that has been in Hermetic concepts for a while. But this by itself is like a separate concept, which is that there is this kind of supernatural domain above the physical world, or non-material plane, where the demons and the gods and the angels and the supreme God all dwell somewhere, and then what goes on up there parallels what goes on down here. Like what's going down here is a manifestation, a lower order manifestation of what's going on farther up. So you have like, it's like an emanationist concept, right? You have the top level, there's emanations going on, but then there's those emanations are mirrored in their lower level counterparts. And so there's this corresponding, why they call it the principle of correspondence between one and the other. And so the second one is as within, so without. So you think about, obviously the term supernatural is being used in a different sense here, because, supernatural, people commonly think of this as meaning it's outside of science, right? Well, this is not outside science. It's very much inside science, but it's outside. People commonly also think of, I mean, and they'll do this today. Like, dualists will do this, materialists will do this. Dualists will say, therefore, the outside realm cannot be understood with human reason, where materialists will say, no, it simply doesn't exist at all. But they're both wrong about that. There is what you think of as the natural world is the space-time world with matter and energy in it, right? And that's just, everyone kind of naturally assumes that because that's wired into our innate intuitions of the world. Well, you think about that's not really true, though. We know with quantum gravity and quantum mechanics now, where space-time is emergent, and so therefore everything that we're seeing around us is not really there fundamentally. It's there in a emergent sense, but it's not fundamentally there. And as Hoffman pointed out, they're just icon interfaces. You don't collapse the wave function from your reference frame, and well, there's something there, but that something is not a material object in space-time. It's a quantum state that exists outside of space-time, which via old definitions would classify it as supernatural, and people kind of equivocated the, you know, space-time, matter and energy definition with the outside human reason definition, and the two are not the same thing. And so because of that, they have, you know, but it still fits the outside space-time, matter and energy definition. So yeah, so that's the first part, right? So you have, you know, you think of it like you know, a computer game. You have your, I mean, that's, you know, we described before that the world is like essentially a simulation of, not a simulation in the Matrix sense, but in the sense of it's an illusion generated from underlying information. And you then have, well, inside the video game and beneath the video game in the hard drive. Well, what's going on in the hard drive is going to correspond to what happens in the video game. The code does one thing, and that code is then manifested in something happening in physical reality. So,
Sure.
yeah, it's really kind of cool. It's
Yeah, and it just follows from the kind of definition of consciousness that we looked at in the last chapter. These two statements end up mapping onto one another. As above, so below. The general idea that space-time emerges from quantum information in Hilbert space, and so any structure in the world outside has its origins, has you know, a parallel or correspondence in that realm beneath space-time. And then since our thoughts are mental, and mental things exist in this realm, so that's where our thoughts are situated.
yeah,
And
well,
so
that's the cool thing. They bring the
our
quantum
thoughts-
cognition in. Like our
right.
state, the whole thing with like, what's your favorite ice cream? I forget if you did this last
We've
time or
done
not.
this before. Yeah, I've said pistachio before to you, I think. Right now I'm favoring cookies and cream.
Okay, so yeah, but the whole thing is like your thoughts literally behave like quantum states in Hilbert space, and the argument is that that is because that's exactly what they are. And so that above world, you're actually more associated with it than you realize. Your above world is actually your interior world, and so you have this
Right.
kind of weird thing where you're actually connected to that outside space-time realm that is generating this, in, you know, the space-time. No, your mind is not generating the whole thing, mind you. You've got a very tiny percentage of very you're basically controlling what's in your head, and that's about it. But you know, it's the same concept. You're having a very tiny little, you know, slice, as it were, of Hilbert space. And the idea then is that the rest of these quantum states are also mental states. They're just not our mental states, and that's what's going on outside space-time.
Right. And then the interesting thing to me is this next section in the book. So once we establish this correspondence between what's going on in our mind and what's going on beneath space-time, they're somehow the same. We also have the idea of multiple planes. Now, here we've kind of, if we tally it up, we have the world of representation, the simulated world. We have our thought world, which itself is a subset of that broader Hilbert space beneath space-time realm. Now, where do these different planes come in?
Well, that's an interesting thing. That's okay. So they talked about. I saw that, and I was kind of confused about that at first, but it seems that basically what they were saying is there's this like a mental plane and a spiritual plane and so on, and a physical plane. And the idea there is that what you're calling, they're basically just, so the physical plane is obviously the physical world. The mental plane, though, and the spiritual plane, what they're really just saying, it's all mental in the way we would think of as mental. If you're talking to a cognitive scientist, they'd be like, okay, that's all mental because it's your cognitive states, right? But they're kind of differentiating there in a more subtle way. They're saying basically the mental plane would be like your thoughts, whereas your spiritual plane will be your feelings and emotions. They're both cognitive states, you would agree, and that's how we would treat them in cognitive science. But what they're saying here is they're basically partitioning this cognitive space, right, into their shared inner space, you know, into this two subdomains, a mental one and a emotional one.
So
Or
what would the implications like ontologically be? So if those emotional states have their own, to use the Greek term, like hypostasis within that beneath space-time realm, then do our emotional lives kind of have a degree of independence from our cognitive life? Like,
well, they can. I mean, you notice how in politics, for example, people, you try and use rational arguments, and you can see very clearly that people are steered by something other than rational arguments. Like they'll give rational arguments, but you can kind of see this as a facade for something. Like they want something and they're going to push for it anyway, regardless of what you do. And so what happens is there's this emotional structure that's underlying what they're doing and driving them to a given conclusion, even though you try and use reason and it doesn't work. Say arguing with a 2-year-old. You can't, the 2-year-old can respond and give proper arguments back, but there's something else driving them. You know what I'm saying?
Well, certainly, yeah. But the question is it independent? Does it have independent existence of the thought world? Also, what's the scope of that extension? Because in
I don't know. Well, I don't know if that's necessarily independent or if that's, well, number one, it can be truly independent because there are the correspondences, right? So they're going to be linked by simply the fact that they're all part of the same reality and they're described the same physics. A thought will be described by a wave function just as much as an emotion is. Given quantum cognition, of course, which materialists won't necessarily agree with the literal interpretation of, but you get the picture. But
yeah. Well, so like for example, Damascus attributes emotional states to like daimonical forces. So what we experience as our own endogenous emotional states actually do have their source in like independent spiritual realities to some degree. So I wondered if a concept
that would make sense. That would probably make sense. I mean, that's where we get to the whole issue of the collective unconscious. So we pointed out, so like the interior space is also the above space, right? That's the as within, so without dictum, right? So that basically sums up the picture being given from the basic physics behind correspondence. It's simply showing the interior of the virtual reality with the exterior, right? And
sure.
so they correspond. Now, what you're getting to is actually, it kind of skips ahead a little bit into what we would call, this is the collective unconscious concept, where, people are driven by, and Jung noticed this. He had, we'll get to that like in a little bit, but in more detail, but basically he noticed that people were being driven by, he was a dream analyst. He would, bring people in and use these dream analyses. And what he discovered was people from all over the world, even if they're culturally separated, they have no contact with each other. There's no, transmission of ideas per se. They're having dreams with the same archetypes in them. And so his argument was that the same imagery was showing. I mean, it differed in like how it manifested itself, but it was always getting at the same basic thing in it. And what he was arguing was that this is coming from this deeper mental reality, and it kind of would fit what you're talking about with the. Actually, it wouldn't just be the spiritual forces behind emotions. Then there'd be spiritual forces behind ideas, I think, too, to some extent.
Yeah.
It's like conception. You think you have the idea that you came up with the idea, but no, it was put in your head somewhere.
Yeah, and in Neoplatonism, ideas do have a kind of life of their own, and we just participate of them. They move through us. It's not necessarily.
That's actually funny. There's a Carl Jung quote where he said something literally to the effect of, these things have a life of their own.
Yeah, they certainly seem to, and it makes sense.
Oh yeah, that quote's right here in this book. He says, okay, so he's talking to a character he calls Philemon in his dreams, and this is actually interesting because I did a video on this concept beforehand. This is actually a professional dream analyst, Paul Foley, and he was like a seminal work in this, but this actually is, believe it or not, a commonly understood thing in this field now, which is kind of weird, is whether or not there's a collective unconscious, because a lot of people won't believe that, but the idea was, and this has been confirmed with studies, is that apparently in your sleep, your subconscious appears to generate separate identities temporarily, and they appear to be able to think. They're able to think for themselves. They found one, they asked them to do like rhyming words, and the seemingly independent character was able to create rhymes as well as do math problems.
Right.
Like, how do you do that if
my own dreams experiencing characters who had knowledge that I know that I don't have, or they have some ability that I don't, like poetry, like the ability to rap, even potentially, things that I can't do, characters in my dreams can do. And how does that make sense?
Well, that's actually been documented. That has been, and it sounds crazy because you might think, well, that sounds like it's some woo-woo. No, it's not woo-woo. Like, even if you're like a materialist, you can, I'm sure most people are materialists when they're in, professional psychology. This is actually in professional psychology papers where they're basically saying your subconscious splits off from you and will create these characters while and they actually have temporary personal identity of their own. I mean, it's there in your dream, and then it's not.
How temporary that really is up
That's
for
the
debate.
question. Is well, the whole point of I did this in my video. I was saying if there's a collective unconscious, well, it may not be coming from your personal subconscious. It might be coming from something that's there before you were born and long after you're dead, which is kind of creepy because it means there's this separate
and this
identity up there that's doing stuff.
Right. It completely aligns with Neoplatonic ontology as well, because souls don't have completely independent existences, the essences of soul. So obviously souls have their energies in time, like we do things in space and time, but the essence of the soul for Platonists is beneath space-time or above space-time in some way, and all souls participate of all other souls to some degree. So that's kind of like the idea with the collective subconscious. And also, it just follows from the idea that space-time is emergent from this deeper level. If that's where thought is, then there's no reason to suppose that our thought worlds privately, our souls, are fundamentally disconnected from one another. They're all, layers or slices of one common structure that's not spatially disconnected. So you would expect the ability for this sort of contact. It's just that the mechanisms behind contacting different entities and
I had a friend who once told me, and this is an anecdote from a friend, but she told me this interesting story where she had a dream one night, and there was kind of a weird character, like it was like a really tall person, like 7 feet tall or something like that, with like butterfly wings, okay, and like blue butterfly wings, and he looked, I mean, it was one with red ones, I think, and one with the red ones said there were two of them, and one of them said, go jump in the water down there. It'll be fun, right? And like they're trying to urge, and she doesn't feel like she's supposed to. So she's kind of creeped out by this. And then all of a sudden she sees a second one. This one like bluish, like light blue wings or something like this. And the other one's like waving. It's like no, don't. And like he points down, right? And she looks down. And there's a bunch of pigs, dead pigs, floating in the water. Okay, like. And then, but she also sees her father up on the hillside with the second entity, right? So it's just a weird dream at first, right? So she tells her dad about this the next morning, okay? She says that her dad's mouth dropped open and he couldn't believe what he was hearing, because then he said he had the same dream the previous night from the second perspective up on the hill.
Wow.
Yeah, and I'm like, listen, like, whoa.
Mm-hmm. Yeah, and of course we can't confirm anecdotes like that,
but it's an interesting story.
Still.
And I've heard a few things like that, so.
Okay, so we have the basic idea of why we might expect these correspondences. And the next section, I think, gets into more of the mechanics on how some of this works. And that was the most difficult section for me, the section on the Hermetic Kabbalah. So, where do you think Kabbalah is a necessary picture here? Do you think there's something that Kabbalah explains in terms of that software of these
before we get there, I thought it might be a good idea to note, because we did skip a little bit ahead here. This is a very interesting description in the Kabbalion, just as a pure physics point of view, okay?
Mm-hmm.
They talk about these vibrational planes, and they have this description. It kind of sounds weird, like what are they talking about? It doesn't even make any sense. Okay, so a dimension, is a measure in a straight line relating to measure, etc. The ordinary dimensions are space, length, earth, width of space are length, breadth, and height, or perhaps length, breadth, height, thickness, and circumference. There's another dimension of created things, a measure in a straight line known to occultists and to scientists as well. The latter have not yet applied the term dimension to it, and this new dimension, by the way, is much speculated about. The fourth dimension is the standard used in determining the degrees, or planes. Now, I want to mention the use of the word fourth dimension here. This relativity had just been invented 3 years ago, so we know the fourth dimension is time. But before that, what you might not know is they had Minkowski in the late 18th century had developed the concept. The mathematicians were developing this concept of a fourth dimension ahead of relativity. And so people were actually speculating about this fourth dimension long before relativity appeared, and they would just that's where that I think his Abbott, his name was, that famous English novel called Flatland, and they had Yeah, so they're talking about this fourth dimension. People are like, well, maybe God lives in the fourth dimension, or all these talks about these things. So they're using fourth dimension in a slightly anachronistic fashion from our modern understanding of it. But
Well, at that point, I mean, just intuitively to me, does make sense characterizing vibration as a kind of dimension, because
you can scale it. It's you can map it to a phase space. You have higher and lower vibrations. There was
sure.
I forget where I saw this. There was a specific reference to that. It was very interesting in the book. Maybe it was in this section. Maybe it was in the other one. And basically, they were describing it as being like a space, but not a space. And they described this well, how is this a space, but not a space, right? And then you think, well, but they said it's like a space, though, right? And I thought this was kind of an interesting description. And what was really you think about that, though, is, well, Hilbert space fits that definition very exactly. Oh, here it is. That's what happens when we go too fast. Okay, so this is in the original as above, so below derivation. Okay, so it says here, at the beginning, we may as well consider the question so often asked by the neophyte who desires to be informed regarding the meaning of the word plane, which term has been freely used and very poorly explained in many recent works about the subject of occultism. The question is generally about as follows. Is a plane a place having dimensions, or is it merely a condition or state? We answer no, not a place, nor ordinary dimension of space, yet more than a state or a condition. It may be considered as a state or condition, yet the state or condition is a degree of dimension and a scale subject to measurement. And so this is very weird because they're describing it as it's like another space. It's not space. It doesn't have physical measurement of, space and time and so on. But a better way of describing it is a domain of reality. It's a different domain of reality. It's in that sense, it's very much like it is a location of sorts. It's not here in physical space-time, but it is a different domain of reality. And yet it doesn't have spatial dimensions. Be like, how does that make sense, right? And then they say it's like a condition, which I thought that was interesting. Well, that sounds kind of paradoxical and, almost nonsensical at first, especially if you're looking at this from a 19th century, early 20th century point of view. But then you realize, well, no, this actually fits the concept of Hilbert space very exactly. I mean, Hilbert space, of course, in mathematics is just an abstraction. But when you're talking about quantum mechanics, it's, whether you identify that with Hilbert space as such, because Hilbert space is just a description still, there is obviously a real domain of reality in which quantum states exist. And they have to, because, entanglement exists. But it can't be in space-time precisely because of entanglement, because it would violate relativity if it did. So it's a real domain of reality in which quantum states exist, and yet it's not in space-time. And then if you tag in the quantum cognition thing, well, the quantum information are mental states, which are, say you're in a happy or sad condition. That's actually a condition, but it's also a domain of reality. And so It's like, whoa, that actually fits the concept. You put them together, you get the Hilbert space concept, then you combine it with the quantum cognition, take quantum cognition literally rather than just a descriptive tool. You combine them and you get, lo and behold, this description that matches what the Kybalion says about 100 years before.
Right. It's also interesting that in one sense it's a plane, but in another respect it describes multiple planes. Like one characteristic of frequencies, like, with modern communication technologies, obviously with like Fourier analysis, we can parcel out all sorts of different vibrational ranges and have signals transmitted in one range that remain kind of independent from signals transmitted in other ranges. So this like domain of vibrational frequencies has the capacity naturally, just given the way that frequency waves combine, to like post a variety of informational structures.
It's like a radio station. You're channeling, you turn the channel on the radio and it's all in the space there, but you're tuning into one or the other. It's a larger space of radio stations. Oh, by the way, the mathematician was Bernard Riemann. I got my history of mathematics. I think Minkowski had some doing with it as well, but Riemann was the first guy to really popularize it. That was late 19th century. Now that you actually mentioned that, it's kind of interesting because they had this is another physics parallel with the Kybalion. And So they have this. Okay, so they talk about these different vibrational domains. Okay, and there are different planes of reality that exist. Them, and they even, the whole notion of occultism, and there are actually beings in these different domains of reality, right? As the Kabbalion notes, these planes are populated with, this is from the Quantum Hermetica, with all manner of beings considered to be supernatural, angels, archangels, demons, even the so-called gods of ancient legend, as well as many more supernatural beings from religion and myth. Okay, so these are all in there, right? Now, here's where it gets weird, okay? I'm sure you've heard of the topic of dark matter, right?
Mm-hmm.
So you see, number one, our galaxy is spinning a little too fast that it should have spun apart by now, okay? But it hasn't. So they realize that there's this extra gravitational force that's holding it in place, additional to what we see with matter. Then they discovered, in some cases, you actually see the effects of dark matter directly, where they see a star literally being pulled apart, and you're like, well, where's it being pulled to? And they look at where the center of gravity is being pulled to. There's nothing there. It's just like they're being pulled into empty space. You're like, well, why? What is that? There's gravity. I mean, it's similar to that one Star Wars thing, the second in the prequels. They had that one planet was deleted from their archives.
Yeah.
And they're like, well, how could there be gravity pulling there when there's no? Well, maybe someone deleted it from the Jedi archives.
Mm-hmm.
It's like that, except that there literally is no. You can look through a telescope. There's nothing there. There's no stars, nothing. It's just empty space, and there is nebular gas being pulled into this, or maybe a star even being pulled apart and being pulled into, like, why is there pulling into empty space? Well, what they're describing here is very interesting. So, as you know, gravity is bent space-time, but space-time emerges from quantum entanglement. Therefore, what you're calling gravity is actually deriving from quantum entanglement or Hilbert space states, okay?
Mm-hmm.
So, well, in one case, you have, matter will produce that. That's something that has quantum states and has a quantum entropy, which, corresponds to a gravity. But you could also have things under domains, which is because, gravity comes from beneath space-time. So therefore, you could, in theory, then have, and he actually talks about this. This is this is the section I'm reading here. Theoretical physics. I have read this actually in an article, I think, once too. Theoretical physicist Eric Verlinde, one of the guys that's associated with studying the holographic principle, has proposed a concept known as modified Newtonian dynamics, or MOND. According to MOND, the gravitational influence associated with dark matter actually derives from the vibrations of underlying degrees of freedom coming from beneath emergent space-time. These degrees of freedom are how entropy is defined in physics, and modern theories of quantum gravity describe gravity as well as a result of quantum entropy. In turn, MOND has accurately predicted the ratio of matter to dark matter, providing good predictive support for the theory. So when you look at the word degree of freedom, it's abstract saying there's differences of things going on beneath space-time. And when you think, well, what are these differences? These differences, and they're saying, well, they're different vibrations. The degrees of freedom are measured in different vibrational degrees of freedom, right? There are frequency domains.
Yeah.
And so you realize what's actually going on here is these are their planes, vibrational planes. I mean, literally, you could think, just say we are encoded in our space-time. There's some other space-time there. It's like literally right overlapping. It's like in a radio station, but because it has, it still has information content, even though we can't see it in our domain, it's still going to produce this entropic effect, which then has gravity. And so you're going to really have gravity just like it's literally like a shadow of gravity from another universe in a sense.
Yeah. Or it's like you're listening to one radio station and a little interference comes in from another. You have the impression of the other frequency domain.
The Pop Science article I saw about this was what they described was, let's say you have a boat on top of the ocean, okay? And the boat's going to produce ripples, gravity. But then you might have sea monsters underneath the ocean. They're also going to produce ripples. You can't see the ripple. You can't see the source of it. Like, well, why is the ripples coming there? Well, it's because it's coming from, you're not able to see in that. It's coming from some other place you can't see, which is beneath the waves. And they actually said they compare that to the ocean is space-time, or the surface of the ocean is space-time, and then there's this Hilbert space, which is the ocean deep. It goes down under, and these.
Yeah. I think the notion is clear enough. I don't understand, obviously, the mechanics of which vibrational frequency domains could influence others gravitationally, or what other sorts of
They
influences
probably
may.
have to be close by. I mean, like in terms
Yeah,
of frequency domain, like in terms of scale, right? Because otherwise, it's not going to, you have a diluted effect that's going to be hard to notice. But
I see.
yeah, so
Just
basically, there's these other. It's like a
in,
shadow gravity.
in music, if you have two notes that are relatively close to one another, the like um, resonance effects are very
Hmm.
clear. But if you have two notes that are very distant, you don't necessarily feel the harmonic relationship of them. So I
That's
guess,
probably a good
like,
analogy. In fact, that's probably mathematically speaking what's going on.
hmm,
I would guess.
interesting. Okay, yeah, yeah. That also kind of raises the question: the Schrodinger universal wave function.
Hmm.
That is, where does that fall in this range? Is that
Well, that's
zero,
all the way at the top.
infinite frequency, or how does that work?
That's kind of weird. That's actually funny because I mean this skips way ahead of the book, but they actually describe that. You want to go there briefly? We'll go to this
Yeah.
some other time too, but
Where is the universal wave function in that picture?
they actually describe the universal wave function in the Kybalion itself, which is kind of funny. They call it the vibration of the all. In the chapter on vibration, the Kybalion also describes the vibration of the all. This too has a precise connection to modern scientific knowledge discovered 59 years after the Kybalion was written. Okay, so they say from the Kybalion, not only this, but that even the all in itself manifests a constant vibration of an infinite degree of intensity and rapid motion that may be practically considered as at rest. And this seems kind of weird, right? Because it's a paradox. Like well, in the one state it's infinite intensity, but then it's also at rest. Well, what does that make sense, right? And so when you think about this, so firstly, just think about the universe, right? So from quantum mechanics, the more energy you put into the Schrodinger equation, the higher the Hamiltonian, the larger the frequency. It's like literally the energy value. The Hamiltonian, when you solve the Schrodinger equation, you get a wave function back. And where the energy value was in the Schrodinger equation now shows up as the constant k in the wave function, which is its frequency of vibration. So it's literally that's direct mathematical relationship between the energy and the frequency of vibration. So you'd think, well, you're going to add all the energy in the whole universe, it's going to keep building on to infinity, right? And then you're
Right.
eventually get like, well, and so then all of a sudden you get like, infinite vibration, right? It
Hmm.
kind of fits that. Well, they had a little problem now, which is kind of weird. And this is what they discovered in 1967 when they actually calculated what the universal wave function was going to be. And they discovered, number one, the time variable drops out. The energy value to the entire universe, and you actually see this now in modern physics lectures on like the origins of the universe and so on, like Lawrence Krauss says his universe from nothing and so on. The energy value of the universe, total energy, is zero.
Hmm.
Well, let's say you have a zero, you put zero as your k value, that's zero vibration rate. It may practically be considered as at rest. Actually, it's literally at rest because it's literally zero energy. And so you have this kind of weird situation where it's literally describing, I mean, that is the Wheeler-DeWitt equation. I mean, they had to derive the whole thing, but when they finished deriving it, it was a very simple realization. They just had, the Hamiltonian of this universal wave function. So it's the universal wave function equals the vibration of the all, right? And then you have, and they go in that particular chapter into more how they show like at least 5 or 6 different parallels between quantum mechanics and the way they're describing vibrations in this, using the concept of vibration in that chapter, which is, some of them are kind of eerie actually, but yeah, so basically it equals zero, and so there you go, it's at rest. Like, well, how did they get that?
Hmm.
It's just totally weird. So it's the Wheeler-DeWitt equation in this Hermetic discussion of vibration. I mean, not in that form, right? But I mean, that's the essence of the Wheeler-DeWitt equation, is the universal wave function. Its vibration rate is zero.
Yeah, there's only really a couple logical possibilities there. If you have this domain of different frequencies, either there's like one starting point that's zero and another that is infinite, and they're separate, or somehow they map onto each other. It seems as though there is a correspondence between like infinite energy and zero energy at some level. Is that
Well, think about it like this, and this is a kind of a hack, but it's kind of a cool way of thinking about it. Just from classical physics, you know that energy is kinetic and potential, right? Kinetic
yeah?
energy is energy in motion. Potential energy is energy in a potential field, okay? Okay, so how much kinetic energy does the universe have overall? How fast? I mean, you got all the moving parts, right? Well, you got to ask when you ask about motion, well, relative to whose frame of reference? And
Oh,
see what I'm saying?
yeah,
I mean, you could be driving in your car, but if someone throws a ball inside your car from your frame of reference, it's only going 1 mile an hour, 3 miles an hour, whereas say you're going 50 down the freeway, it's 53 miles an hour. And so it's all reference frame dependent. Well, then which was the preferred reference? The only way you can think about that is to have an average reference frame for all the parts of the universe. But then you say, well, okay, moving with respect to, well, what's the average reference frame moving with respect to itself? Well, everything in its own reference frame is moving at, you're
zero.
moving
Yeah,
at zero with respect to your own reference frame. So the total kinetic energy of the universe is zero. Now, potential energy is energy inside of a potential field, right? So you have a ball rolled up a hill. The ball has potential energy.
right.
Or a spring, you compress the spring, it has, potential energy in the compression and so on. Well, you think about this, so it has to be inside of so how the universe has to be, to have potential energy, you have to be in a potential field, right? Do you see what's wrong with that statement? The universe inside of a potential field?
Yeah, I mean, where would that potential field be then? I guess, or
Yeah, well, I mean, think about it. The universe is everything physical, right?
right.
Potential field is a physical thing, right?
Mm-hmm.
So if the universe is inside of a potential field, it's not the universe anymore, is it?
Right. Yeah, it's a
There's something
part.
physical outside of it. So literally, the universe is, physically speaking anyway, self-contained.
Yeah.
And so you have this kind of funny situation where, well, if there's all the potential fields are inside of it, it itself is not in a potential field, which means on the whole, it has zero potential energy.
Hmm.
So it has zero potential energy and zero kinetic energy, which is the sum total of all energy, which means the universe's energy is exactly zero.
In terms of vibrational levels, frequency levels in these different
Mm-hmm.
domains, what do you approach as you approach infinite uh, frequencies?
That's an interesting question. I would imagine, well, here's the thing is that you're going to have positive and negative energy. And that's why, it adds up to zero. And so
Hmm.
when you do that, eventually, when you could add all the positive, you can segregate it and you can just kind of build up to infinity in that sense. But then, when you're actually, you combine it all together, the negative is going to cancel with the positive and you're going to have zero.
Right. So the infinite frequency domain would be all the positive energy together.
Yeah.
So
And
I
they're
wonder.
kind of thinking, I guess they're describing in kind of a naive fashion there, where you're just thinking like you add everything together, you're going to get, they're not realizing there's negative energy and that's, going to cancel it out and bring it back down again. But they did manage to get, these two seemingly paradoxical things. Because paradoxically, you think, well, if someone tell how much matter and energy is in the universe, you're like, well, there's lots and lots of it. I mean, we can't even count that. Like, well, no, it's a trick question. So like they're going for the first of the naive intuition that it's just, all the matter and energy combined is going to be lots and lots and lots. And then lo and behold, no, wait, it's also zero. And
Right.
the
That
zero
does.
comes from the actual hard physics, whereas the first part is describing the kind of naive intuition of you're adding all the energy together in the universe and you assume there's going to have to be some very high number.
Yeah. It's still not clear to me though what, if we have these different levels of vibrational frequency, different domains basically, that are real in Hilbert space, what is it that you're, and I've asked this before already, but what is it that you're approaching as you ascend in frequency? If you add everything together, it's zero. But if you just add, higher and higher frequencies, what's the asymptote there?
That is an interesting question. I don't know the answer to that.
Okay. Well, like in Hinduism, there's the idea of Brahman as kind of divinity itself, which might be that zero energy.
Yeah.
And then there's Ishvara Koti, which is like Godhead, infinite intelligence, you might say. So maybe it's I don't know, something like that. Um, So next is this discussion on the Kabbalah. And like I said, this was the least clear to me because I'm not that familiar with the Kabbalah. So where's the explanatory power in the Kabbalist framework, and how exactly does it function as a software?
Hardware analogy. Okay, so basically what's going on there is you have, oh, we finished the part with the Jungian component. So basically the collective unconscious. We talked about that to some
Yeah,
extent,
we
but
talked about it quite a bit.
basically
Yeah.
a lot of the inner space is subconscious to you. So the Hermetic Kabbalah, basically what's going on there is Hermeticism obviously has this as within, so without, as above, as above, so below concept, which is corresponding outer space with inner space, or lower space with physical reality with upper supernatural reality, right?
Right.
And so it says emanationist framework, which is Neoplatonic in nature, and you have start with basically God on top, and it emanates on down, and then the lowest plane is the physical world. So Hermetic Kabbalah, meanwhile, is also emanationist, but so Hermeticism is associated with like kind of explaining how the physical comes from the non-physical in this correspondence, right? That's like the hardware. It's like you have your hard drive and you have your computer screen.
Yeah.
And you put stuff in your hard drive and it's going to manifest on your computer screen. That's your correspondence principle. Whereas Kabbalah deals with the emanation chart, and that's the tree of life, deals with the emanation chart going through the shared inner space.
The structure of the code, yeah.
The structure of what's going on in the hard drive, yeah. So basically, it's Hermeticism is telling you what you see on the screen is coming from your hard drive, and Kabbalah is telling you what's in your hard drive.
Okay, so how does Kabbalah do that? The block sphere analogy is
that's the thing. Now, I don't know, because I mean, this is just what they had in the book, but so they go through this whole tree of life concept. But what was very interesting is they mentioned this in the it's a detail, really, is what it is. The Sefer Yetzirah, or Book of Creation, is described. This is what's going on behind creation. Okay, and as you may or may not know, in Kabbalah, the world is spoken into existence from God's speech. It's like it's describing an information code, that's what's going on behind space-time. And the Kabbalists even have this reference to they call that world the veiled reality. We live behind the veil, and it's kind of funny because there's a physicist, a French physicist, Bernard d'Espagnet, who said basically the same thing from quantum mechanics. He says, what's going on behind space-time is with quantum mechanics is there's this veiled reality. We are seeing physical world, but that's not what's really going on. There's this, what we're seeing as space-time, matter, and energy is this kind of veiled illusion, as it were. It's as Hoffman might say, an icon interface. And what's reality is this thing we're probing with quantum mechanics, but we don't get a clear picture of because it's literally outside of space-time. And so, so Kabbalah says the same, even described it, and he described it as a veiled, like a veiled reality. And it's kind of funny because it's literally the same thing. But now the Kabbalists are saying, this is behind the veil. This is what's part of doing the creation, right? And so they're saying, well, this structure, and I don't know what else is in, because I haven't read the Sefer Yetzirah, but I know this they describe this in the book here. This parallel, there's a distinct structure that you would expect. So we know something about what's behind the veil from physics, right? That's Hilbert space. And so they describe a distinctly Hilbert space structure inside of, existing in this beyond space-time veil, right? So the world beyond space-time, right? Behind the veil. They describe this one thing in the Sefer Yetzirah, and then when you compare it to quantum mechanics, well, what's the world behind the veil? That's Hilbert space. So we have this structure, and they call it a block sphere. It's a representation of a qubit, and that's what's being described as existing behind Hilbert space, okay? So let's look at the comparison, okay? So this comes from the Sefer Yetzirah, and it gives a description of a 22-level block sphere. These 22 letters, the foundations, he arranges on a sphere with 231 modes of entrance. If the sphere be rotated forward, good is implied. If in retrograde manner, evil is intended. For indeed he showed the mode of combination of the letters, each with each, Aleph with all and all with Aleph. Thus, in combining all together in pairs, are produced these 231 gates of knowledge. So the block sphere, this is from the physics of it, okay, and this is all referenced. They have the citation from Quanticky, which is the academic reference on this. The Bloch sphere is a mathematical representation of the state space of a qubit. Here, states are arranged on the surface of a sphere in pairs. Okay, there you got your parallel there, two of them on the surface of the sphere and in pairs, with an axis for each pair of states. Pure states, meaning single states, are on the surface of the sphere, whereas mixed states or permutated combinations of the pure states are located within the sphere. Now, what's interesting, you mentioned that it's located within the sphere. Okay, so he has the 22 letters on the surface of the sphere, right? With 231 modes of entrance. Well, modes of entrance into where? Inside the sphere. And it's funny because the combined states are located within the sphere. The pure states are on the outside. So you have the 22 letters on the outside, and then the permutations, the 231 permutations on the inside in the Sefer Yetzirah. Whereas the Bloch sphere, you have the pure states, the single states on the outside, and the qubits on the inside, the superpositions on the inside. As it's very funny because it's like this is describing a qubit. Now it gets a little more interesting. Okay, so each permutation corresponds to different superpositions of states, which would process a different probable outcome within the quantum state. And then, let's see here. And then go on to pointing out how operations are done on a qubit. So remember, in the Sefer Yetzirah, they say you rotate the sphere and they produce either an evil or good outcome, depending.
Yeah.
Okay, guess how operations are performed on a Bloch sphere.
Rotation, right?
Rotation. You rotate the qubit, and it produces spin up, spin down. It's kind of funny. It's likewise, operations are done on the qubit through rotations of the Bloch sphere, with different rotations corresponding to different outcomes. This appears to correlate the example given of evil intent and good intent, ultimately corresponding to different rotations of the sphere in the Sefer Yetzirah. Though only one example of these peculiar similarities to quantum computing would seem to describe letters in superposition in Hilbert space. Given that the context of this passage isn't describing the creation of the universe with these letters, remember, space emerges from quantum information, this would seem to first fit with the general science described before behind Hermetic correspondence, as well as with the synthesis of Hermeticism and Kabbalah described here.
Okay.
And it's funny because it's a picture-perfect example of it's a Bloch sphere in Hilbert space, and that's what's existing.
Now,
is
there chirality in the rotation of the Bloch sphere, as it seems to be the case with the Kabbalist interpretation, where if you rotate it one way, it's good, the other is bad? Is there an asymmetry in terms of left-right rotation with the Bloch sphere?
That I don't know. I think there might be, because it's well, I mean, you rotate. Yeah, actually, it is. You rotate in one direction, it's going to produce one outcome. The opposite direction, it produces the other outcome. Because that's the whole, spin up, spin down. It's depending on how you collapse the wave function this way, the other one's going to have the opposite state, and so on.
Okay, so this sounds like an operation that's being performed, right? Is this the basis of quantum cognition in some sense, or what sort of
activity? It would have to be. It would
right.
have to be, because this is the basis of quantum computation. And, when we talk about quantum superposition, everything is, you think of just quantum superposition in the generic sense. There's Schrödinger's cats in superposition. It explains entanglement. It explains qubits, etc. However, if you go to quantum information theory, you realize that there really is only one type of superposition, and that is qubits. I mean, because what is information? Information is a measure of differences. When you have a computer, you have ones and zeros. Well, those are described with, little bits of information. Say the magnetic field is going one way versus the opposite way. There's going to be, it's going to be read off as a 1 or a 0, but that could be anything. It could be, spin orientations or states of electric charge or whatnot. It doesn't really matter. It's just that it's a measure of differences. And as long as you have a binary of those differences, you're measuring information. And so literally anything can be a qubit. And ultimately, people like Seth Lloyd, they'll say, well, the universe is literally a quantum computer because it's all qubits at bottom. You don't think of these other things. You don't think of Schrödinger's cat as being a qubit, but Schrödinger's cat literally is a qubit.
Okay. Is there any unique interaction between a qubit and a classical state that might is there a way in which we perform particular measurements on the qubits in our own mind, and is that just like extremely general, and all cognition is that process of measuring and then like looking at the probability space again as a qubit, or because Kabbalists are interested in like manipulating these in particular ways. So it seems like
Right.
if this is a form of software, it should give us a clue as to how to consciously control these sorts of operations in our mind.
That's actually interesting. I mean, I suppose if you have like evil intent or good intent, I mean, they correspond to different operations, right? Rotations. And so if you
Mhm.
can link that up to some other thing, that's actually a very interesting question. It's just kind of funny. I mean, you theoretically you could, I suppose, like you could have, you know, thinking this thought rather than that thought will trigger an effect of some kind, and
Mm.
or trigger an entanglement of some kind, and you have some secondary effect it produces.
Okay, so do you think that the our cognition is always in terms of quantum information, or is there a kind of dialectic between classical states and quantum states here?
That's a good question. Well, in terms of our choices or decision making, it appears to be universal that all of our decision making is of this nature, which is where it would happen. So I mean, when you're thinking about like a straightforward logical puzzle, you're not necessarily going to be trying to make choices there. You're trying to and even a quantum computer is going to be thinking through in a straightforward fashion about a problem. So the only time it would really become apparent is in when you're making choices. And so the whole reason that quantum cognition appeared in the first place was precisely because they were measuring human choices, particularly in this case in the stock market. And they discovered that these choices were actually modeling with the Schrodinger equation. And so they're like, oh, and they realize, well, what's the stock market? Well, that's the reason the stock market's obeying the Schrodinger equation is because the individual traders on the floor are obeying the Schrodinger equation. And they realize, oh, wait a minute, this isn't just an economics thing. This is a human choice thing. And they then broadened the scope to this, and they realized, oh, human choices in general they behave by the Schrodinger equation.
Right. Okay. The individual letters, just refresh me. In this example, um, individual letters represent individual quantum states, or the combinations in the
Right?
sphere.
The individual state, they're like the ones or the zeros. They're the
In terms
individual,
of
those are the pure states.
in classical information, then.
Yeah, the classical information being
Yeah, it's
superposed. Yeah, that's what's being superpositioned.
right. Okay. So the number 22, there's no like scientific significance to that in particular, is there?
That's an interesting question. I don't. One thought that I had, I know that's the Hebrew alphabet, and that's important in Kabbalah. But the thought that I had, and this is just a speculation, is superstring theory deals with 10 spatial dimensions, and the reason for that is you can't. It turns out that you can only have why 10. Well, there's like 3 and 10. You cannot have. Apparently, it's a math thing. It has to do with integral products, and certain spatial operations will not work except for in 3 dimensions or 10 dimensions. And it's like basically the space becomes certainly in some senses certain operations in it become incoherent if you're dealing with dimensions other than those. I mean, there may be other like versions of that, like farther out, like 26 dimensions or whatnot. But basically, what we're dealing with superstring theory, that's why they think there's 10 dimensions. Is they can explain all this stuff with the 10 dimensions, but they can't. You try and drop down to like you could go up to 11 dimensions, drop down to 9 dimensions. You can't do it because it doesn't have integral products. I think it was integral products. Anyway, and so you have 10 dimensions, and you have also a temporal dimension for time. And so when you think about that, it's 11 dimensions, 10 space plus 1 time. And well, you can then orient yourself. You think about what's on the sphere. You're rotating the qubits, the pure states are located on the surface of the sphere, and they're on axes. Remember, I think they even mentioned on axes in the Sefer Yetzirah example. Each dimension has 2 directions. East or west, north or south. And so there you have, it could be that may be where the 22 is coming from. It could be referencing the dimensions of, spatial orientation.
Yeah. Okay.
It's a guess.
Yeah. There are 11 lines connecting 22 points 1-to-1, I guess, through the sphere. But that's something I don't understand. I still don't fully comprehend how Kabbalah is supposed to contribute to understanding of like the mechanics here, like
Well, what's
information.
being said here is, I mean, I'm not an expert on
Yeah,
Kabbalah, and it doesn't seem like the authors of the book are particular either, except they know the basic concept of it. And what they're describing, they're using this detail to show that, because I have heard of the term Hermetic Kabbalah before, and this is, this is an actual thing. Hermetic Kabbalah is an actual thing. Okay, so in occultism, they've combined Hermeticism and Kabbalah, and they call it Hermetic Kabbalah. And so the thing with the Hermeticism side is that it's dealing with solid physics. Okay, and so then they're saying, well, is there something to this Kabbalah thing? Because the two match so well, we might find some physics in the Kabbalah. And then lo and behold, we do find some physics that complements the physics in, when you're dealing with a program. I mean, you can program a program anyhow, so any which way. So if you're going to look for physics in a program, it's going to be in the specific mechanics of how the bits exist in the first place.
right.
So you would be looking, if you're going to find any physics in there, I mean, the rest is going to be like a program, right? So it's like, I mean, that's not going to give you anything specific physics wise, but you could find it in the kind of information used. And in this case, we do find that, and they describe basically a qubit, which matches the physics in the Hermeticism.
I mean, it makes me want to look at a little bit more of the Kabbalah
There
stuff.
might be more clues. I mean, it'd be interesting to read through the Sefer Yetzirah with a fine-tooth comb and see if you could find any other hidden clues in there to see if there's even more physics we haven't discovered. So,
Yeah.
I mean, this whole thing seems like a work in progress. Like this is like a really excellent like foundation for this kind of research.
Mm-hmm.
But I mean, like this whole thing kind of comes. I mean, when I saw this, at first when I saw this on my Idealism and Science versus Atheism page, I'm like, oh, we got some weird kind of either New Agey or esoteric. I mean, the kind of thing you might see on the Ancient Aliens show or whatnot. And then I go there, and I was like, I think I told you I was depressed that time, so I like didn't even bother with it for some years. And then Kyle Allender starts making videos, and I'm like, well, this is interesting. And I discover, oh, look at all this. There's all this physics here. So it's like there's almost like a textual equivalent of an archaeological dig. Like
Yeah.
some of it might be nonsense, or you might dig through it and something like, oh my, look what we found here.
Right.
Like you dug this piece out of the dirt and like, or out of the text, and lo and behold, we got a big chunk of physics here.
Enigmatic and intriguing. So still,
Yes, I mean, it's definitely a work in progress. It's not like, I mean, it's they got enough for the full Hermetica, and they got enough to basically form the template to combine Hermetics and Kabbalah. But like beyond that, like how much of it is, is it just gobbledygook? People, some middle age mystic wrote or something, or are they getting this from somewhere? Or is it a combination of both at the same time? Is some gobbledygook and some actual stuff? And it will literally take looking through as the fine-tooth comb.
Yeah.
Like find all the dissect it, as it were.
The last section I thought was much clearer. And I think that just kind of follows from everything that's been said about Hilbert space, the collective subconscious, etc. And that's the Platonic intuition of the forms. I mean, Carl Jung and Wolfgang Pauli in their dialogues even discuss like the existence of these archetypal structures in the collective subconscious and in like that realm beneath space-time. And they identify them with the Platonic form. So this
it's interesting. I had an old friend who once gave me a book on Carl Jung and Wolfgang Pauli, and it had a complete set of their correspondences. And I was reading through it, and it was very interesting because you can see that. And Wolfgang Pauli was very afraid about publishing this stuff because he's like, "What are my colleagues going to think of me?" But it was in private, in these private letters, they were talking with each other, and it was very apparent that they thought there was like. They knew they suspected strongly that this new physics at the time, then it was new. Now it's not new anymore. But Wolfgang Pauli is one of the kind of the 6 founding fathers of quantum mechanics, and he's like, there's something here, and it's tying to, he said, like alchemy, and it's like it's crazy. And you see this in their notes. They're private when they think no one's listening. And these could get published posthumously after both of them died. But you see the correspondence to the fact, and they're like, "Oh, they think there's magic in the physics, and that connects to the collective unconscious." And they're like, "They think there's something here," and it's kind of funny seeing this. But Yeah, they were onto something like the quantum hermetica before the quantum hermetica. They just didn't have, I guess, the big enough picture to put it all together yet.
Right. But this insight about
Something
Platonic
like this.
forms, I think it ontologizes the Platonic forms very well and makes sense with modern physics, and I really have no problem with it. I mean, could you just kind of briefly summarize
Yeah,
what's
well, so basically you have, in physics, you have this inside space-time realm and this outside space-time realm, and that fits very well with idealism, because if idealism is true, the physical world is like a dream in God's mind. So you got your inside the dream, and you got the, what Neoplatonists call the pleroma, which is the hard drive, God's thinking that's generating the dream, and that's outside space-time. But then you think, well, we have access to that too, even as a small aspect of it. And so what are those? Those are thoughts. Thoughts are ideas, right? And you ask the question, well, number two, where is number two? Let's say I open your brain up. I'm going to find number two there. Is it in your car? Under your bed? This is a nonsense question, yet it exists. And so it doesn't make sense to say that a form is somewhere particularly in space or time, or maybe the idea of a cube, I mean, not a cube itself, but the idea of one is not in space or time. It's a Platonic object floating out there.
right.
And so this kind of cool thing, this is, what you think of as the pleroma, as it were, and there's these ideas floating out there, and they're not in space-time, yet they exist. And so then you combine that with the idealist intuition, you realize, well, you see a cube in your mind. Well, that cube is a Platonic object, and if idealism comes from this, you can, intuitively grasp that with realizing that dualism is incoherent, yet the mind can't be material. Then you have this kind of weird realization that what we're seeing in front of us, you say, on the Skype thing, you see the red, discontinue button and the blue microphone button and the blue camera button and all that. Well, red and blue, and there's a white for the X out thing, right? Those are all things that are manifesting in space-time in the dream, and yet they have to come if they're manifesting there, they have to be upstairs in the pleroma, right?
Right.
So you have, these colors up in the pleroma, as it were, but they're not as actual physical colors, they're mental colors, and they're manifesting in space-time. So,
Well, sure. Yeah, if our thoughts are in the realm beneath space-time, and when we have
and then there's correspondence, then you have a correspondence, because you have the idea outside and the thing inside.
Right.
And then sometimes, of course, you can get this a little more interesting. This is where synchronicity comes in with the Jung's thing, where you say, like, sometimes things will be, like, here's an example, a raven, right? It's just, he have an example of this because it actually showed up in Jung's, description of this. We had okay, so basically when you see a raven, what comes to mind other than a raven, a blackbird?
Death, right?
Yeah, and it's kind of like a spooky death. It's like you expect to see it like in a horror movie, it's kind of pale gray outside, and then something bad happens, and you see this raven suddenly shows up and starts screeching at you, right? Mm-hmm. Well, he had this example where I think it was like a hospital case where he mentioned, and this is one of the Jung books my friend gave me, but he had this thing where someone dies, in the exact moment of their death, some ravens start flying overhead, or they can screech, and it's like, well, how did that happen?
Right.
There's this correspondence going on, and the thing is that it's mentally associated. It's not just in our minds; it's mentally associated in this larger subconscious, and because of that, because that mental correspondence is happening, it's what's generating our world. You're going to end up seeing these spooky coincidences happening inside our, sometimes that's what he called synchronicity. And it's kind of, because the reason for that, it seems spooky, but then you realize the reason for it, and you're like, it's still cool and weird, but it makes sense as to why. It's the simulation is being generated by the same subconscious archetypes that we're associating mentally things together with. So,
right. Our thoughts are in that domain, so we would expect to have direct access to these archetypes, these kind of simple forms, but also they are producing the world around us, and they have relations between each other kind of prior to their emergence into space-time.
Right.
So forms aren't in isolation. You can't just instantiate one form and expect it to be a one-to-one correspondence. When you instantiate the one form, when it appears in the world, the network
come up with everything else that it's entangled with.
Right. yeah, so it does make sense of synchronicity and a bunch of other things. And I mean,
He
this
had
is
a really good
getting,
example of synchronicity in that book, in that one of the stories. There's this one patient who was giving him it was telling him about a golden scarab beetle in a dream analysis, right? And the window was open and it was kind of shady inside. They didn't want, too much light in there. And it's kind of funny because beetles don't usually fly into dark places, right? Well, at that exact moment, a golden scarabaeid beetle, which is the closest North American equivalent to a scarab beetle, flew in through the window at the exact moment the patient's telling, the woman's telling him the dream.
yeah.
It's like, how does that happen?
Right. Yeah. Jung describes quite a few incidents like that with patients, but it's all interesting stuff. And this is, I mean, it's still a little sketchy, but overall, I think the picture is coming together. So next time, we'll move on to the next section. And just let me see, what is that?
That's on the different phenomenon, of course, here with like it is like it kind of explains how to use mentalism and correspondence in like how it comes to explain certain things that you normally would think of as paranormal or supernatural or whatnot. But
So we dipped our
it does so
toes
in a way that makes sense.
already, like how this mechanics and software uh, relates to spooky phenomena, paranormal phenomena, and now next time we'll go in depth in that. So it should be fun. Thank you, Johanan, and we'll talk soon.